Hello, today we're going to look at the STEP question from assignment 11 of the STEP support programme. So this question's got two parts. The second part looks longer because it's also been split up into A and B. And the first part looks as if it might be helpful, maybe as an idea for doing the rest of the question. So first of all, in this first part here, it does say to find the real root of the equation. Where in this part, it says roots. So the first part is telling us to expect that there's only going to be one root of that equation. Sometimes in STEP questions, you'll see something that looks like this. So that means there might be one root, there might be more than one root, and we're trying not to give away what sort of answer to expect. Okay, so let's... another thing you might see is you might see all of the roots. And again, that's not really giving away whether it's one root or two roots. But this one, we're expecting that only to be one. So let's start by using the substitution. We have square root of x equals y, which means that x is equal to y squared. And let's substitute that in. We've got x plus 3 root x minus a half equals 0. Substituting in these, this gives me y squared plus 3y minus a half equals 0. Let's multiply by 2. 2y squared plus 6y minus 1 equals 0. I don't think this one factorizes, so let's use the quadratic formula. Y is equal to minus b plus or minus the square root of b squared minus 4ac, so that's plus 8, all over 2a. And if you like, you can sing the quadratic formula to the tune of Pop Goes the Weasel. I'll leave you to work out that for yourself. Okay, so I'm going to simplify this a bit. This is minus 3 over 2, plus or minus. I'm going to divide by a factor of 2 again. Inside the square root, that means divided by a factor of 4. So this is 9 plus 2 over 2. So this gives me y is minus 3 plus or minus the square root 11 over 2. Now at this stage, it looks like we've got two possibilities for y because we've got this plus or minus going on, but we're only expecting one root. So what you have to do at this point is just think about what the question, what the substitution means. And here we've got square root of x equals y. Generally speaking, a square root is always positive. So something like this, it means the positive square root of x. You might, if you want to get a negative as well, you'd have to put plus or minus on the outside. It also tells you here, y is greater than or equal to 0, just in case you didn't know that the square root sign is defined to be the positive square root. It's also told you that y has to be greater than or equal to 0. And down here, if I took minus 3 minus root 11, that's definitely going to be negative. So since we know that y is bigger than or equal to 0, y is equal to minus 3 plus root 11 over 2 only. And so x is equal to y squared is equal to 1/4. If we square this bracket, we're going to get 9 plus 11 minus 6 root 11. I think so. Square that term, and double the cross product. So this gives me, let's say 20 minus 6 root 11 over 4. And then I can divide by 2 to get 10 minus 3 root 11 over 2, and just squeaking it into the bottom of the page there. Okay, so for that part, you needed to just read the question carefully to make sure that you spotted that it was only one root. And the question also told you how to work out those only one roots. It explicitly told you that y was positive. So that's the first part of the question. Let's go on to the second part. Okay, so we'll assume that we're maybe doing the same sort of thing as before. If we compare this to the previous part, we use the substitution root x equals y. to try and deal with this. Let's try and do something similar here and make y equal to root x plus 2. Let's get my drawing thing back again. So for part A, we're going to let y equals root x plus 2. And again, y is going to have to be positive. That then gives me that y squared is equal to x plus 2. So that means that x is equal to y squared minus 2. So let's substitute in for this and this. The equation is x plus 10 root x plus 2 minus 22 equals 0. X is the same as y squared minus 2. Root x plus 2 is the same as y. So we get this equation, and we can simplify it. Y squared plus 10y minus 24 equals 0. And I think this one does factorize. If I do y plus 12, y minus 2 equals 0. Yeah, I'm pretty convinced about that. So this gives me y equals minus 12, or y equals 2. Oops, so 2. And then this one isn't a solution, as y has got to be bigger than or equal to 0. Okay, so it's a good idea when you have something like this just to stick. Well, we haven't actually solved it yet because we haven't found x. So x is equal to y squared minus 2. So x is equal to 2 squared minus 2, 4 minus 2, which is 2. And if we substitute it in, x plus 10 root x plus 2 minus 22 equals 0, we'll get 2. This stage isn't strictly necessary, but it's a good idea just to test your solutions. So we get 2 plus 10 times 2 minus 22 equals 0. I'm pretty happy about that. Let's just have a look at what happens if we took this erroneous solution. So I'm going to do this in red to show that this is not correct. So if we take that erroneous solution, this then gives me that x is equal to 144 minus 2, which is 142. And then the equation, x plus 10 root x plus 2 minus 22 equals 0, will then become 142 plus 10 times square root of 144 minus 22. That is very definitely not 0. So something else you can do when you're doing an equation like this is just check your answers in the original equation, as long as it's not going to be too horrible. And then you'll see that actually that solution was an erroneous solution. So when you're doing things like having an equation and squaring both sides, which is another way of tackling this question, or using a substitution like this, you have to be a bit careful to make sure you're not introducing more solutions which are solutions of your changed equation, but were not solutions of the original. So go back, check your answers in the original. So that means we have one solution here, and we have, I'm just going to clear all these so that I can just write it in the top. We have x equals 2 only. Okay, let's look at the next one. So this looks considerably trickier, considerably more tricky than the first one. But let's just go with what we used before. Let's let y equals the square root of 2x squared minus 8x minus 3. And y is bigger than or equal to 0, as before. So I'm not trying to think too much about this question. I'm just doing what worked in the previous two parts and hoping that it works in this part as well. If I square both sides, I get this. Okay, and what I'm going to do, if we look, we've got a 2x squared and a minus 8x. That looks very similar to this. So what I'm going to do now is I'm going to take the equation plus root that stuff, minus 9 equals 0. I'm going to double it. So I'm going to get 2x squared minus 8x plus 2 square root of that stuff minus 18 equals 0. Being careful to make sure that I actually multiply everything by 2 and I don't miss one. 2x squared minus 8x, this is the same as y squared plus 3. This thing under the square root was y, so this is plus 2y, and then minus 18 equals 0. This is now looking much happier. And this is another case where I can factorize. So we've got that. This gives me the solutions y equals minus 5 and y equals 3. Again, we know that y is positive. So we've just got this part. So we've got y equals 3. Therefore, we've got y squared equals 2x squared minus 8x minus 3. So 9 equals 2x squared minus 8x minus 3. So 0 equals 2x squared minus 8x minus 12. So we have this, unless I've gone wrong, but I'm pretty sure that's right. This doesn't factorize, so we're going to have to use the quadratic formula again. That's 24 all over 2 minus b plus or minus square root of b squared minus 4ac. So this gives me 2 plus or minus root 40 over 2, which is 2 plus or minus root 10. Okay, so it looks like we've got two solutions, which might be okay. It's not a bad idea just to check that these work. It's going to be a little bit more, oops. It's going to be a little bit more work than the last time. But let's just get rid of these. I'm trying to get rid of one side so that I've still got my answer on the other side, which does mean it takes slightly longer. Oh, there we go. We'll go with that. Okay, so as a check, if we've got x equals 2 plus or minus root 10, then x squared is equal to 2 plus or minus root 10 squared, which gives me 4 from squaring this term, plus 10 from squaring this term, and then the cross term is going to be plus or minus, depending on whether it's a plus minus here, 2 lots of 2 times root 10. So it's plus or minus 4 root 10. We get 14 plus or minus 4 root 10. So if we take, so what I'm trying to do is I'm trying to actually check both solutions at once, which might go horribly wrong, but we'll just go with it. Okay, so x squared is 14 plus or minus 4 root 10. X is 2 plus or minus root 10. This thing under the square root we know is equal to 3 because that's what we were solving. Okay, and we've still got the minus 9. So this is 14 plus or minus 4 root 10. We've got a minus 4 times 2, it's a minus 8. Minus 4 times plus or minus root 10. What you can do is you can write that now as minus plus 4 root 10. And what's that saying is that if this one is a plus, this one is a minus. So it's just showing you that the sign is flipped. Okay, so these cancel. And we've got 14 minus 8 is 6. And then plus 3 minus 9 equals 0. So I'm pretty happy with that. Okay, so that question, the first part was trying to help you through the rest of it. And by saying explicitly y is greater than 0 and saying explicitly there's only one root, it was trying to help you work out for the other parts how to make sure that you don't include the erroneous roots. And then the last part is a little bit more involved, but having worked through the previous two parts, it makes this part a lot more accessible than if you'd just been given that last part by itself. Right, well, thank you very much.